Okay, so this is Unit 2, Lesson 9. Vocabulary review. A blank is a polygon with all sides and angles congruent. Yes?
Square.
Everybody's been saying square. A square is this type of polygon, but I need you to be more general. Unisa?
Parallelogram.
Nope, not every parallelogram has all the sides and angles congruent. Kalila? Nope, not every quadrilateral has all the sides and angles congruent. Think about our discussion. Yes? Nope, not all the sides have to be congruent on a rectangle. You can have one of these can have all the sides congruent and angles congruent. Henry?
Rhombus.
Nope, a rhombus doesn't have to have all the angles congruent.
Trapezoid.
You played yourself.
Nope.
Regular polygon. Regular polygon. Oh. That is not.
A regular polygon is any polygon with all congruent angles and congruent sides. You said square, and that is an example of a quadrilateral that is a regular polygon. But I need you guys to think in more general terms. So any polygon where the angles are all congruent and the sides are all congruent is a regular polygon. Got it? Okay. Now, can somebody give me the definition of a rhombus? What's the definition of a rhombus? Nathan?
A quadrilateral with all the sides are congruent.
Yes, a rhombus is a quadrilateral. That means there's 4 sides and all the sides are congruent. Now, is every square a rhombus? Yes. Is every rhombus a square? No, not every rhombus is a square. Very good. So let me go ahead and draw a rhombus. And so here's one side of my rhombus. And I copied that. And so here's another side of my rhombus. And if you notice, all the sides are congruent, right? All my sides are congruent. That's a rhombus. And so something else about a rhombus, oops. What other properties does a rhombus have besides all the sides are congruent and they are parallelogram? What else do we have about, else do we know about a rhombus? It's a parallelogram. All the sides are congruent, so I'll mark that all the sides are congruent, and I'll mark the sides saying that it's a parallelogram. So parallelogram means that for the 4 sides, there are 2 pairs that are congruent, that are parallel to each other. That's what a parallelogram is. Okay? There's one more thing about this shape that we haven't said. It is a quadrilateral. Okay? So here's my rhombus. Okay, now I want to draw a trapezoid. Who can tell me what a trapezoid is? Jeremy, what's a trapezoid?
It only has one pair of parallel sides.
Nice. There's only 2 parallel sides. There's only one set of parallel sides. So I'll go ahead and draw a trapezoid. Okay. And if you notice, we have 2 sides that are parallel, and I'll go ahead and mark them right here. Okay, that is a trapezoid. Only 2 sides are parallel. A parallelogram, there are 2 sets of parallel sides. A trapezoid, there's only 1 set that are parallel. Parallelogram, 2 pairs that are parallel. Trapezoid, 1 pair that are parallel. Got it? Okay. What else do we know about trapezoid? It's a what? Quadrilateral also. All right, and then who's got the last one? A rectangle. Who can tell me about a rectangle? All the way in the back. Joshua.
Okay, so a rectangle is a regular polygon or a quadrilateral that has all right angles but they aren't congruent sides.
No. It doesn't say that they don't have to have congruent sides. It doesn't say anything about the sides. It just says that all the angles are right. So it is a quadrilateral, and all the angles are right angles. So that is correct. So And then, yes, very good. It's also a parallelogram. So it has 4 right angles. That is a rectangle. It is also a parallelogram. Okay? And can a square be a rectangle? Yes. Okay. So, any questions about these 4 shapes? Yeah, and it's a quadrilateral. So actually, all these 2, 3, and 4 were all quadrilaterals. Yes. A rhombus, they can be right. They don't have to be right. That's why a square is a rhombus, because it's just saying the sides are all congruent. Okay. But
That's what makes it also like a parallelogram.
right, and it's a parallelogram because all the sides are congruent. Okay, so what you'll learn, I'm going to go and read this because I haven't made the video for the YouTube channel. You already know about some three-dimensional figures. You see them in many ordinary objects around you. If you know how to classify three-dimensional figures, you can describe the shapes of the objects you see. Here's the new vocabulary: three-dimensional figure, face, edge, prism, and base. A three-dimensional figure or solid is a figure that does not lie in a plane. A flat surface of a solid shape like a polygon is called a face. Each segment formed by the intersection of 2 faces is an edge. So I have a prop, and you won't be able to see this prop in the video, but I'm going to hold it up. It's a box. You guys see my box? Okay. So each of these, do you guys see each face? How many faces are on this box? There's 6. The one in front, the one in back, top, bottom, and then the sides. That's 6 faces. Now, this box is, actually it's called a rectangular prism, okay? And they're talking about the face. And this face has what shape? This is a rectangle, right? And then this face meets this face at this point. It's called an edge. Do you see the edge? So where 2 faces meet, they meet at a straight line called an edge. Do you understand? Okay. Now we have many edges on this box, but where the edges meet, they form a corner that we call a vertex. So that's not too different than what we thought of with triangles, right? Or other polygons. Where the sides meet, they form a vertex. Okay, well, where the edges meet, they form a vertex of the prism. Got it? Now, a prism is a three-dimensional figure with 2 parallel, congruent polygonal faces. Okay, so we name a prism based upon these 2 faces that they call bases. Okay, they are parallel. That means if those faces were extended infinitely in both directions to form a plane, those planes would never cross. They're parallel. Okay, so if we take a look at this figure to the right, if you notice, the sides are rectangles. Those are the sides of the prism. But it has a base on the bottom and the top that are parallel. Do you see that these two bases are parallel? Do you guys see that? Okay, and what shape forms the bases? What shape is that? Hexagon, because it's 6 sides. So this is called a hexagonal prism. Do you see how the prism is named based upon the bases? Are we good? Okay, so you have to know what the bases, what those shapes are in order to name the prism. The sides of the prism are always going to be rectangles. Now, if you have a rectangular prism where all the sides are squares, it's not called a rectangular prism anymore. It's called a what? A cube. So a cube is a specific type of rectangular prism where all the faces are squares. Are we good? Now, let's take a look at this. A pyramid, the sides are all triangles and they all meet at a vertex. The base, in this case, we have a base, and my base we're looking at this from an angle, so it's hard to tell if this base is a rectangle or if it's a square that we're just looking at from an angle. So since a square is also a rectangle, I'll go ahead and call this a rectangular pyramid. Okay? And so the base of the pyramid is where the name for the pyramid comes from. Are we good? So since a rectangle has 4 sides, that means there are 4 triangles that make up the side of the pyramid. Do you understand? And those 4 triangles meet at the vertex. Okay. Now, have you guys ever seen a prism, mess with a prism? And you see that the prism actually splits the white light up into its colors that make up the white light? Okay, do you guys understand how color is, it's the reflection of visible light off of something? So when we're wearing black, it's not color. Black is absorbing all the lights, all the colors in the light spectrum, right? Does that make sense? But whenever we see color, it's what's being reflected back to us. Do you guys understand? Okay, so that's why when it's sunny outside, they say don't wear dark clothing because that's absorbing more light in the spectrum. Do you guys understand? Okay, so that was in the book. I just want to mention that really quickly. A cylinder has 2 congruent parallel bases that are circles. So we're starting to talk about 3-dimensional figures that have curved surfaces. And if you notice, my base on a cylinder is actually a what? A circle. These circles are parallel to each other. And the bases are flat surfaces. Now, you can call the top and the bottom of the cylinder faces because they're flat. But anything that has a curved shape to it, you can't call that a face. Got it? So the side of the cylinder is not a face. Now, has everybody here opened a can with a can opener? Do you sometimes leave the lid attached to the can?
Yes.
Okay. And then you just dump out whatever's in there?
Yes.
Right? I want you to think about that for when we get to nets. Do you guys know what a net is?
Yes.
A net is basically if you have a container, like a can or a box, and you cut the container so that if you laid it flat, that shape would be the net. Does that make sense?
Yes.
So have you guys everybody here seen an empty roll of toilet paper, right? Yeah. If I was to cut along the length of the roll and flatten it out, what would it be? No, it wouldn't be a net. It would be a what shape? A rectangle, right? Now, I could make it a net for a cylinder because an empty roll of toilet paper is just a tube. But to make it a cylinder, I need a top and a bottom, right? What would the top and the bottom have to be? Circles. So if I had circles on both ends, okay, and if I cut along the length of the cylinder, flatten it out, and I had the 2 circles attached to that rectangle, that would be a net. Do you guys understand? That's what I was trying to get you guys to think about the can and leaving the lid attached so that you can bend it back down to cover. Do you guys understand? So nets, that's kind of how nets work. All right, so moving along. Here's another shape, and it has a curved surface, but it does have one base. It has one face that is flat. And what is the shape of the flat surface on the cone? It is a circle. Now, something I want to point out to you. So remember the formula for diameter and area of a circle? Okay, you had to know the radius or the diameter, right? Okay, now there's a formula for the area, the surface area for the net of a cone. And you still have to know this bottom shape's radius. And the bottom shape of a cone is a what? It's a circle, right? So that means that there is a radius here. Okay, but you also need to know one more bit of information. You need to know, what am I drawing here? You need to know h, the height. Okay? Same with the cylinder. There's some formulas for cylinder. And in order for us to know how to calculate the volume or the surface area of the cylinder, we need to know the radius as well as the height. You guys understand? Now, moving on to the last three-dimensional figure we're talking about? It's a sphere. A sphere is a set of all points in space that are the same distance from the center point. Now, do you guys remember how we drew with, what was the tool we used to draw a circle? We used a compass, right? And when we drew with the compass our circle, we used the spike as the center. Did we draw a very good circle if our compass opened or changed the distance? No. In order for us to get a really good circle, right, we had to draw a curve where every point on the curve was the same distance from the center, right? So we didn't want our compass to open. Well, we were just drawing points in one plane. That's what gave us a circle. But if we were able to fix and draw points in 3 dimensions, that's how we would draw a sphere. Every point is the same distance from the center of the sphere. So often, a sphere, they'll draw it in a way that if you were to cut the sphere in half into 2 hemispheres, anybody here ever cut an orange in half? Yes. If we look at those 2 halves, what do the halves show us? Well, what shape do we get if we cut an orange? We get hemispheres, but what shape do we see on the flat part that we cut? A circle, right? Okay, so a sphere that has a plane going through the center of the circle, it would form a circle. And again, to find the area, the surface area of the sphere, we would need to know the radius of the sphere. Does that make sense? So there's a formula for that too. If we wanted to find the volume or how many cubes would fill up the sphere, we would need to know the radius of the sphere. Okay? Now, look at the architectural blocks. Name 3 right here. What is that shape? That is a cylinder. Okay? And then it says here, name 1 and 2. I don't see 1. Actually, I think this is 1 right here. I think you just can't see it. So they want you to name 1 and 2. What is figure 1? It's not a prism, a rectangular pyramid. Mm-hmm. There's an octagonal pyramid. There's a pentagonal pyramid. Google it and you'll see what I'm talking about later. Okay, so who can tell me what the object 2 is? Cone. Yep, that is a cone. Okay, do you see any other shapes here that we've just learned about? Right. There's a couple of these, but here's one of these is a rectangular. Prism. And then it's okay, but let's just name the shape, not specifically what type of triangle it is. Just say a triangular prism. So you have right here a triangular prism. Okay? And that's about it. There's a few more shapes in there, but we've named the different types that are present. All right, so you can use graph paper to draw 3-dimensional figures. So I'm going to go ahead and draw a hexagonal prism, but first tell me, what do my faces have to be in order for it to be a hexagonal prism? A hexagon, right? So those 2 faces have to be parallel to each other, and they need to be the same shape, right? So would you like for me to draw a hexagonal prism sideways or a hexagonal prism that stands up and down? Okay. So I'm going to go ahead and draw it sideways because most people came out and said sideways first. So here we go. A hexagon has how many sides?
6.
Now the sides that I can't see, I'm using a dotted line to draw those sides. Okay? That looks kind of messy. I'll fix that up. Okay, but if that's one of my faces, I need another face up top, right? So I'll go ahead and draw another one up top. And it needs to be identical.
It's fun.
Okay? And the edges that we can see, I make solid lines. The edges that are on the other side of the shape, I make dotted lines. So I can see an edge in the front and the side.
Is this gonna be? Are we gonna do stuff like that for like exams and homework?
For the most part, you just need to identify what they are. Now, there is an edge that we can't see on the back side over here, so I'll make those dotted. Okay? That's a hexagonal prism. When you guys take notes, I've noticed that some of you guys are starting to draw your figures more often. That's good. By the time you get to high school geometry, I want you guys to be able to draw a little bit better these figures that we're starting to see. Now for the next one, a triangular prism. How do I draw a triangular prism?
3D triangle.
And would you like for me to draw sideways or up and down?
Up and down.
Sideways. All right, so since the people that wanted the first picture drawn sideways didn't get their way, I'm going to draw this one sideways. But the bases have to be what shape? They need to be, nope, that's a rectangular prism. I need to make a triangular prism. So I need to start out with one of my faces as a triangle. So let me go ahead and do that. Okay, that's a triangle. And then the side faces are rectangles. How long do you want those side faces to be? I'm going to make them 6, length of 6. So 2, 4, 6. 2, 4, 6. And then if I start over here, I got to do dotted because this is behind. That's 4. Okay. 2, 4, 6. And now this, I can't see this edge back here, so I'm going to dotted line that. And from here to here, dotted line. And then the face that I can see. Are we good?
Yay.
All right. So we're almost at the end of the lesson. A blank has 2 congruent parallel bases that are circles. What?
Cylinder.
A cylinder. Very good. Okay, which three-dimensional figure does not have a base? A sphere. There's no flat surfaces. The other ones have a flat surface that we would call the base, okay? Who can describe the base of this first shape and tell me the name? What's the base of this first shape? Nathan? There's, no. Come on.
This is a prism.
Yeah, what is the base?
He said name the base, I didn't name it.
But would we name the prism that? A cube? There, that's what I'm looking for. It's a rectangular prism. Remember, a cube means all the sides are what? All the faces are what shape? Right, are all these faces square? No, we have some rectangles in there. So the base would be a rectangle. This would be a rectangular prism. Okay, who's got this middle one right here? First of all, tell me what the base is. What's the shape of the base? Yes.
Triangle.
Right, it's a triangle. And what's the shape? What's the three-dimensional figure then?
A triangle prism.
A triangular prism.
Triangular prism. Yeah, that's ours.
Okay, and then the last one. Who can tell me what is this shape? Unisa, thank you. What is a pentagonal prism? Right. So if you look, this would be my base, and there are 5 sides. That means it's a pentagon. These bases are parallel to each other, so it is a pentagonal prism. Okay? And that is it for my lesson today.